So we want to use the composition of functions to determine if two functions are inverses. So remember that with composition of functions, you must find f of g of x. And so finding f of g, we're going to start with our f function. That's the 3x plus 9. And in that x position here, we're going to put our entire g function. So that is a 1/3 x minus 3. We will distribute the 3 into this parentheses. So 3 times 1/3 is 1. So we get a 1x, or just an x. 3 times a -3 will give me a -9 plus 9. -9 plus 9, those subtract out, leaving me with just an x. Then I need to find g of f of x. So I need to go the other way with my composition. So I'm going to do 1/3, and then in place of my x, I'm going to put the f function here. And so I will have 1/3 times a 3x plus 9, and I will distribute that 1/3 in here. Multiplying by a fraction is similar to dividing by this denominator. So think of this as 3x divided by 3, which would just be a 1x. 9 divided by 3 would just be a 3. And then I would have this minus 3 out here. So this 3 minus 3 would subtract out, leaving me with just an x. For these two to be inverses of each other, both f of g of x and g of f of x must equal x. They don't need to equal the same thing, they must equal x itself. So yes, these two are inverses of each other. Now let's look at b. Let's look at h of k of x. So I'm going to start with a -4 x plus 2, and in place of my x, I'm going to put that -1/4 x minus 2. And so I'm going to have negative times negative, which is positive. 4 times 1/4 will give me a 1x. Negative times negative is positive. 4 times 2 would give me an 8 plus 2. So I get an x plus 10. So since this already doesn't equal just an x, I technically already know that this is not going to be inverses of each other because I don't have it just equaling an x. But let's go ahead and do the k of h just to be on the safe side. So I'll have a -1/4 minus a 2, and in place of that x, I'm going to put a -4 x plus 2. So a -1/4 times a positive 4 would leave me with a 1x. -1/4 times a positive 2 would actually leave me with a -1/2 minus 2. So this is going to leave me with an x minus 5/2. So these two do not equal x. It's not that they don't equal each other, it's that they don't both equal x. So no, these are not inverses of each other. Let's look at m and v. So let's start with m of v. of x. And this one, I'm going to have a plus 1 and a plus 2. And in place of those x's, I'm going to put a 2x plus 1 over an x minus 1. A 2x plus 1 over an x minus 1. Now, in order to get rid of these fractions within fractions, I'm going to multiply each term by that denominator of an x minus 1. So I'll multiply each of these by an x minus 1. When I do so, what that's going to do is this is going to cancel this out. It's going to divide out these denominators, but it's going to leave this 1 times x minus 1 and 2 times x minus 1 over here. So I'm going to have a 2x plus 1 plus this 1 times an x minus 1. So that's going to give me plus an x minus a 1 on the numerator. And then I will have a 2x plus 1. And then I'm going to multiply this 2. So I'll have plus 2x minus 2. And then I'm going to simplify the numerator and the denominator. So these 1's will simplify out. And so I end up with a 3x on the numerator. Oh, and I totally messed up. This should have been a minus 2. So this should be a minus 2x and a plus 2 here. So that way that these two x's will simplify out, leaving me with a plus 1 and a plus 2, which is a 3, so this equals x. So that means that we do need to look at v of m of x. And so here I have this 2 times x plus 1, and then I have this x minus 1 on the denominator. So in place of this x, I'm going to put an x plus 1 over an x minus 2, x plus 1 over an x minus 2. Now again, I'm going to multiply each term by this x minus 2. So I'm going to multiply both of these, this plus 1 and this negative 1. I'm also going to multiply this term by it and this term by the x minus 2. Now when doing so, this x minus 2 and this x minus 2 will divide out, leaving me with a 2 times an x plus 1. Here's the 2, here's the x plus 1, plus a 1 times x minus 2 on the numerator. On the denominator, these will divide out, leaving me with an x plus 1 minus a 1 times x minus 2. Now let's distribute and simplify. So we've got 2x plus 2 plus an x minus 2 on the numerator. We have an x plus 1 minus an x plus 2, because negative times negative gives me a positive. So these will cancel out or subtract out, leaving me with a 3x. The x's will subtract out, leaving me with a 3. So that simplifies into an x. So yes, m of x and v of x are inverses of each other. Now let's look at this last one. We have w, not v. We have w and p, so we're going to do w of p of x. So we have 2 over And then in place of that x, I'm going to put a 6x plus 2 over x, and then I have this plus 6. Now I'm going to multiply every term by this x. So I'll multiply here by an x, by an x, and by an x. That way these will divide out. This will leave me with a 2x on the numerator. On the denominator, it will leave me with this 6x plus 2 plus a 6x. So I have a 2x on the numerator, and I have a 12x plus 2 on the denominator. Now the only thing that I could do here is divide each of these terms by a 2, and so I'd get x over 6x plus 1. This is as far as I could simplify this. Now, knowing that this is as far as I could simplify, I could technically go ahead and say that no, these are not inverses. But I'm going to go ahead and look at how it would look with P of W of x. I would start out with 6, and then I would put in a 2 over an x plus 6 plus 2 over a 2 over x plus 6, because these would be where my x's are. I'm going to multiply each of my terms by an x plus 6. So I'll multiply by an x plus 6 by an x plus 6. That way this will divide out and this will divide out. So on the numerator, I will have a 6 times 2 plus 2 times x plus 6. On the denominator, I just have a 2. So I end up with 12 plus a 2x plus 12 divided by 2. So I have 24 plus 2x divided by 2. I can simplify that into 12 plus x, but now notice this still doesn't give me an x by itself, so the answer is still no, these are not inverses of each other.